This is a video where I am walking through the solutions of the worksheet for my honors physics class for problems related to force of friction. Real quick, let's refresh our memory. Force of kinetic friction is equal to the coefficient of kinetic friction times force normal. Force of static friction is less than or equal to the coefficient of static friction times force normal. When I'm equal to, that's when I'm at my max. So force of static friction maximum is equal to the coefficient of static friction times force normal. So refresh. Okay, so here we go. We read the problem, we draw a sketch, we label, we draw free body diagrams, and we solve. We know that in number 39, you want to slide a 0.27 kilogram book across the table. If the coefficient of kinetic friction is 0.11, what force is required to move the book with a constant speed? So I'm drawing the book on the table. The dot represents the center of mass. I'm going to have to push the book with some force applied. They told me that there's a coefficient of kinetic friction, so I am implying that there's friction. If it's kinetic friction, that means it's sliding. So let's look at all the things. Let's see, what else have I learned? I have 0.27. I know the mass is 0.27 kilograms. That's in kilograms, so I don't have to convert. They told me that the coefficient of kinetic friction was 0.11. What is the force? So they're asking for how much force applied I have to give it is required to move the book with a constant speed. Constant speed is a very important phrase. V is constant. The way I drew it, it would be to the right. If I have a constant speed, then acceleration is 0. Next thing I do is I draw a free body diagram. Force normal, force of gravity, which equals mg. And I have force applied, and I have force of kinetic friction. To the left, it opposes motion. If acceleration is 0, then we know that all the forces have to add up to 0. We know that the forces added up in the x direction must equal 0 because that's 0. We know the forces in the y direction must equal 0 because it's not accelerating in the y. So that's a pretty important statement, constant speed. I want to know how much force is required, and force is in the x direction. So I will start by solving in the x. So sum all the forces in the x direction. They will add up to 0 because acceleration is 0. There's two forces. Force applied is positive minus force of kinetic friction because it's to the left. So I will say force applied is equal to force of kinetic friction. They didn't give me the magnitude of kinetic friction in the problem. That's okay because I can calculate it. And it was found to be mu sub k times force normal. Well, they didn't give me the force normal in the problem, so I got to solve for force normal. I can sum the forces in the y direction. They all add up to 0. I have one positive. I have one negative. And we will find that force normal is equal to force of gravity, which is mg. So force applied is equal to mu k mg. Now I can plug in numbers. 0. What was the coefficient? 11. 11 times the mass, 0.27 kilograms, times the magnitude of acceleration due to gravity on Earth, which is 9.8 meters per second squared. And we find that that equals 0.87 newtons. And that is the answer for the question. Next, same exact problem. We're going to slide a book across the table. Kinetic friction is 0.21, the coefficient that is. What force is required to move the book with an acceleration of 0.18? So this time, it's not constant speed. I'm actually going to accelerate. So the surface has friction. I know this because they gave me a coefficient of kinetic friction. Here's a picture of the force that I'm going to apply to it. They tell me the mass. They tell me the mass of the book is 0.39 kilograms. They tell me the coefficient of kinetic friction is 0.21. There's no units for kinetic friction coefficient. They also tell me that acceleration, per how I'm drawing, is going to be to the right, was 0.18 meters per second squared. Free body diagram, force normal up, force of gravity down, force applied to the right, force of kinetic friction is going to oppose motion, so it's to the left, and acceleration, per the way I drew it, is to the right. So that means the sum of the forces this time can't equal 0 because I'm accelerating. So I'll start from the same problem. Sum of the forces, again, they want to know how much force is required. That's in the x direction. Is equal to mass times acceleration in the x. This time I can't cross that acceleration off with 0 and set everything equal to 0 because acceleration is not 0. I still have two forces in the x direction. It is force applied as positive. I subtract the one that's to the left, which is a negative force. Mass times acceleration in the x direction. I have values for mass, I have values for acceleration, but I'm going to leave the symbols there. Once again, I'm trying to solve for force applied. Force applied is equal to mass times acceleration plus force of kinetic friction. They didn't give me the magnitude of kinetic friction, so I have to use the formula for kinetic friction. All right. The formula for kinetic friction is mu k times force normal. Force normal, once again, since acceleration is 0, happens to equal force of gravity. So I can plug in to that equation for force normal mg. And now I'll solve it. The mass was 0.39. The acceleration was a positive 0.18 plus, this time it was 0.21 times again 0.39 kilograms times force normal, which was, oh, no, sorry, not 9, I'm sorry, little g is where I was at, meters per second squared. Okay. All right, so then I plug that into my calculator, which you should do, and you will find the answer to be 0.87. I just noticed that I copied my answer down wrong. So the answer to the first problem was set up properly, but I looked at the wrong answer, 0.29 newtons. Apologize for that. Okay, continuing on. How much force is required to start a 14 kilogram flower pot sliding if the coefficient of static friction between the pot and the surface on which it rests is 0.64? So I have a flower pot. I have my tulips. I'm sitting on a surface that has friction. It's a rough surface. And I'm going to put a force on it. And I put a little force, and then I put a little bit bigger, and I put a little bit bigger, and it still won't go. I have to reach a certain amount of friction, I'm sorry, force, in order to break what? So if you recall, static friction will reach a maximum, and then I will drop to a constant kinetic friction. So this is my kinetic friction region. This is my static friction. And this is where I hit my maximum. Okay, this is the force applied versus the force of friction versus force applied. Okay, all right. They want to know how much force do I have to do in order to get it to start moving? So where am I at? I'm at the maximum. We are at max, or let's say it another way. Force applied has to overcome force of static friction max. So if I want to know at the just to start, right? Start sliding. So I'm at my maximum. I've got to be just at that number or slightly above. Okay. So let's draw a free body diagram. Force applied, force normal, force of gravity, which equals mg, which equals weight. And then it's not a question about where I'm at on that static friction. I'm at the maximum. To get it to slip, I got to be at max. So sum of the forces in the x direction is equal to mass times acceleration in the x. Now, when I'm just about to slip, we will say that the acceleration is 0. Okay? So force applied minus force of static friction max is equal to 0. Force applied has to equal force of static friction max. And now we'll plug in some numbers. Okay, so force applied equals force of static friction max. So what is the definition of force of static friction max? It is equal to the coefficient of static friction times force normal. In this case, we can see that force normal is equal to the force of gravity. It is not always equal to that. So I will just go ahead and add that. If you don't know how to find force normal, you can sum the forces in the y. It's not accelerating in the y, and you'll find that force normal equals force of gravity. So now I can plug in numbers. Force applied has to be equal to mu sub s times mass. Mu sub s, what do they give us as the value? Well, we forgot to put that up there, huh? Mu sub s equals 0.64. Mass equals 14 kilograms. 0.64 times 14 kilograms times 9.8 meters per second squared. I have a kilogram meter per second squared. That's good. Should come out to a Newton. That is equal to 87.8 newtons. The key thing on this is acceleration is 0 because I'm just about to slip. Okay. I have an 11 gram coin with an initial speed of 1.8 meters per second. It slides 0.86 meters across the table. I'm probably going to run out of room on this. I'm going to work it off to the right. Okay. And then it comes to a rest. A, what is the coefficient of kinetic friction between the coin and the table? B, will two 11-gram coins stacked one on top of one another have the same initial speed as a single coin? I'm sorry, and they're having the same initial speed as the single coin slide a smaller distance, the same distance, or greater distance just before coming to a rest? Explain. I'm going to draw the picture up top. I have a coin. It's sliding across a table, so it has a velocity this way, but it's coming to a stop. Okay. Velocity is 1.8 meters per second. This must have friction. We know that mu sub k is equal to 0. Oh, we don't know what that is. We have to answer the question. Hold on 1 second, please. Okay, so I've drawn a picture sliding across the floor. it comes to a stop. They told me the initial velocity is 1.8 meters per second. And let's see, what else did they tell me? They tell me that the mass of the coin is equal to 11 grams. We're going to convert that. How do I convert that to kilograms? I take 11 grams, I divide by 1,000 grams in 1 kilogram. So the mass of the coin is 0.011 kilograms. Let's see, anything else they tell me? Think, oh, it goes some distance, delta x, which is 0.86 meters. Okay, final velocity is 0. All right, so comes to rest. How did I know that? I'm going to draw a free body diagram. Force normal, force of gravity, force of kinetic friction. How did I know it was kinetic friction? Because they tell me it's sliding. This is what people will want to do. They will want to apply a force applied. Where's the force applied? There is no force applied. Someone has started it pushing, and it is now traveling and slowing down because of kinetic friction. The finger is not on it. They did not describe a finger on the coin. The first question, A, ask, what is the coefficient of kinetic friction? Mu sub k equals question mark. Okay. Well, mu sub k is in the force of kinetic friction equation, and force of kinetic friction is in the x-axis. So I'm going to sum the forces in the x direction equals mass times acceleration in the x direction. They didn't tell me this was traveling at a constant speed. They actually told me that it was slowing down and coming to a stop. So there is an acceleration, and we were not given the acceleration, but we have enough information to solve for the acceleration. Velocity initial was 1.8, velocity final is equal to 0, and delta x is equal to 0.86. So we will have to use the equation. I'll do it over here. V final squared equals V initial squared plus 2a delta x. I will find delta x to be equal to V final squared minus V initial squared over 2 times a. Excuse me, I'm solving for acceleration. Same equation though. 2 times delta x. 0 minus 1.8 squared over 2 times a positive 0.86 meters. And assuming my solutions that I worked several years ago are correct, it's 1.88 meters per second squared. So now I know that number. I wasn't given it, but I had enough information to solve for it. All right, how many forces are in the x direction? Only force of kinetic friction, it's to the left, so it is negative equals m times acceleration in the x. And we'll plug in numbers later. Again, what am I asking for? I'm trying to solve for mu sub k. So negative mu sub k times force normal equals mass times acceleration in the x direction. In this case, force normal and force of gravity, I'll use a different color, happen to be equal to one another. There's no acceleration in the y direction. So I can move force normal over. We're going to divide because that's what we're going to do. We're going to divide by negative force normal. So mu sub k is equal to m times acceleration times the negative force normal, which is again equal to mg. Now I'll plug in numbers. Mu sub k equals the mass, which is 0.011 kilograms, times the acceleration, which was negative 1.88 meters per second squared, divided by a negative of the mass, which was 0.011 kilograms, and g is a positive 9.8 meters per second squared. Notice the negatives cancel. That's good because mu k is a positive number. I found that to be 0.19. That's the answer to A. B, what happens if we double the mass by having 2. So let's draw it. I have exactly the same force diagram, except this time it's equal to 2 times mg, force of kinetic friction. Look at this equation right here that we solved for mu sub k. Mu sub k is equal to, what happens to mass? I should have done that up top. These masses cancel. I could have just divided the acceleration divided by g. So mu sub k was equal to acceleration over negative g, which was acceleration was negative 1.88 over negative 9.8 meters per second squared. And I don't care how many coins you have, as force normal goes up, the mass cancels. So same is the answer. All right. 95. 55-kilogram baseball player slides into third base with an initial speed of 4.6 meters per second. If the coefficient of kinetic friction between the player and the ground is 0.46, excuse me, what is the player's acceleration? So here is the player sliding into third base. The velocity initial is 4.6 meters per second. They told me mu sub k is 0.46. Slides in, and they didn't do a very good job of telling you that the velocity comes to a stop, but he slid and came to a halt on third base. So velocity final is 0. What else do I know? Mass is equal to 55 kilograms. Don't have to convert. They tell me that, okay, they want to know what's the player acceleration. So the first thing you might want to try to do is use 5, 4, 3, 2, 1, because I want to know the we don't know delta x. We know velocity initial. We know velocity final. We don't know acceleration, and we don't know time. I only have 2 out of the 3 things I need in order to solve for the other ones. So because I only have 2, UAM equations won't get you the answer. But there's another way to find acceleration, and that's using sum of the forces equals mass times the acceleration. So here's a free body diagram of the player as he slides. And the only force that's acting on him is force of kinetic friction. So we know that acceleration has to be to the left, and we can find it. We can sum the forces in the x direction. Mass of the player is times the acceleration is equal to the sum of all those forces. I only have one force of kinetic friction, and it's to the left, so it's negative max. What's the equation for force of kinetic friction? Force normal equals max. Just in this case, force normal equals force of gravity. So I can say mu k mg equals max. Notice that mass cancels. I can divide both sides by mass. What am I trying to find? I'm trying to find acceleration equals question mark. So I'm trying to get a sub x all by itself. So negative mu k times g equals a x. I can plug in numbers now. Negative 0.46 times 9.8. And I find that to be 0.46 times 9.8. And that will give me a sub x equals negative 4.5 meters per second squared. Does it make sense that it's negative? Yes, because it is slowing down. Okay. Where am I? A car accelerates at 12 meters per second squared without spinning the tires. So I have to think about that for a minute. There's a reason why they tell me that. Okay. Determine the maximum coefficient of static friction between the tires and the road. I'll tell you what that is. So imagine a tire. Tire is turning this direction. Okay. So if you think about the contact with the road, if there was not static friction, the tire would just sit there and spin. For example, the imagine a perfectly slick surface on ice, the tire would just spin. It would not actually move the car forward. It's the force of static friction. It's opposing motion. Which way does the tire want to slip? It wants to turn that way. So which way is force of static friction? Force of static friction is actually going to oppose motion. It's to the right. So it's actually kind of, that's on the tire. Okay, that's the tire's force of static friction direction is to the right. On the ground, I will have the same force, but pointing to towards the other direction. So there's the force diagram. It's to the right. Force of static friction is to the right. Force normal is up. Force of gravity is down. Determine the minimum coefficient of static friction between the tires and the road to make this possible. So I got to sum the forces in the x direction that is equal to mass times acceleration in the x direction. The only force now is force of static friction, and that is equal to mass times acceleration. Mu sub s times force normal is equal to mass times acceleration. Force normal happens to be equal to force of gravity this time as well. Mu sub s mg equals ma sub x. What do we know that happens? That mass cancels. And we find that in order for this to happen, mu sub s has to be at least equal to acceleration divided by g, which is equal to 12 meters per second squared divided by 9.8 meters per second squared, and that will be equal to 1.22. And there is no units because meters per second squared over meters per second squared cancel. So it had mu sub s has to be 1.22 or the tires are going to slip. All right, that's the end of my solution video.